Hello, my name is Nick Reed. I am the founder of Reed Mobility and a trustee of the charitable partnership RoadSafe. The history of technologies to support road safety is essentially as old as the motor vehicle itself. Whether it is headlights and windscreen wipers or automated vehicles and smart motorways, a range of technological interventions exist to help mitigate and manage road risk as part of the safe system approach to road transport. This short presentation examines current and near future applications of technology that could support safer road use. Many technologies support drivers in avoiding collisions by either intervening directly in vehicle control or warning the driver about particular hazards. These are known as primary safety systems, and examples include ABS, AEB, autonomous emergency braking, parking sensors, lane departure warnings, tyre pressure monitoring, traction control. Regulations are increasingly making such technologies mandatory on new vehicles, with the European Commission's General Safety Regulation requiring new vehicles to include a suite of safety measures from 2022. While technology helps to prevent collisions, it can also play a vital role in mitigating their worst effects. These are known as secondary or passive safety measures, with examples including seat belts and pretensioners, crumple zones, passenger airbags, laminated glass, and whiplash protection. Tertiary safety refers to the post-crash situation. A key example is eCall, the system mandatory in new cars in Europe since 2018, which automatically contacts the emergency services in response to a serious collision. A further tertiary safety system is event data recorders, systems that record key parameters about the operation of a vehicle in a rolling buffer and store that information in response to a kinematic trigger, such as a severe deceleration associated with a crash. Event data recorders are becoming increasingly prominent as a source of evidence to understand why crashes occurred, and are one of the systems being made mandatory for European new vehicles within the General Safety Regulation. Automated driving systems have the potential to change the driving task dramatically. One of their earliest implementations is likely to be automated lane keeping systems, or ALKS, which will manage steering, accelerator and brake functions at up to 37 miles per hour on motorway roads. Successful implementation of ALKS may help us proceed confidently to higher levels of automation, but there are concerns about whether ALKS will be sufficiently safe and whether human drivers might misuse it. Until technology and legislation permit automated driving, human drivers remain fully responsible for safe operation of their vehicles. However, as vehicle technologies provide more support for the driver, the allocation of the tasks necessary for safe driving can change. For example, if adaptive cruise control and lane guidance systems are managing the longitudinal and lateral control of a vehicle on the highway, there is a risk that drivers can become inattentive through distraction or fatigue. Driver monitoring systems tackle this risk using cameras to monitor the alertness state of the driver and provide escalating warnings if they fail to demonstrate appropriate levels of attention. Safety monitoring can even begin before a journey starts. Alcohol ignition interlocks prevent a vehicle from being started unless the driver supplies a breath sample that is below the required limit. Such systems have been used successfully on public service vehicles in Sweden and are available for use in the rehabilitation of drink driving offenders in other countries, including USA, Canada, Australia, Belgium, Netherlands, and Finland. Beyond specific monitoring of the driver, many systems are now capable of monitoring and reporting driver behaviour, often called telematics. Some use inbuilt vehicle technology, some use additional dedicated hardware, some use technology within smartphones. All use the location of the vehicle and measurement of its dynamic properties to assess driving risk. This information can be used by insurers within pay-as-you-drive or pay-how-you-drive policies, or by fleet managers in overseeing the safety of their colleagues who are driving for work purposes. Technology plays an increasing role in driver education. The hazard perception test, introduced in the UK in 2002, requires prospective drivers to indicate when a hazard emerges when watching videos of predetermined driving scenarios. Training and testing drivers in this skill builds on research findings that hazard perception ability was inversely correlated with the risk of fatal or serious road crashes. Since 2015, the filmed live action clips have been replaced by computer-generated versions, making it easier to update imagery and create scenario variants. More recently, a series of studies for the RAC Foundation by Nottingham Trent University has shown that presenting hazard scenarios through a virtual reality system can make hazard perception training even more effective. In-vehicle technologies could, in future, offer more guidance in the use of advanced vehicle systems. For example, before making an advanced function available to a driver, the system could require each driver of the vehicle to watch instructions and demonstrations provided through the in-car screen while safely parked, to show them when, where, and how to use that function safely. With technology allowing vehicles to have a greater sense of their location and surroundings, it becomes possible to support drivers in complying with traffic regulations. An example is intelligent speed adaptation, a system that can moderate vehicle speed to stay within the posted speed limit. This system uses speed limit maps to determine the applicable speed for the vehicle type and location, and cameras to detect any temporary speed restrictions, for example roadworks or in controlled motorways. It can then either moderate vehicle speed directly as needed, or can provide alerts to drivers, warning them if they are exceeding the speed limit. A wide range of technologies are applied to support the monitoring and management of traffic flows on busy regions of the road network and to improve safety. An example is loop detectors in the road to monitor vehicle presence and speeds, which can then be used to trigger traffic management measures, including driver information and introducing variable speed limits. Increasingly, there is the opportunity for communication between vehicles and from roads operators to drivers and vehicles to support safe and effective journeys. This includes transmitting information about upcoming traffic, weather, or road conditions. The application of this technology must be associated with assurance over the veracity of such communication. One aspect of safety technology is the ability to enforce traffic regulations. Speed cameras are deployed to monitor and encourage speed compliance at specific locations. Average speed cameras measure vehicle speeds between 2 or more locations and enable censure of drivers who travel faster than permitted between these measurement points. Such measures improve safety by encouraging drivers to adopt speeds that are appropriate for the road environment. Speed enforcement on controlled motorways also helps to improve traffic flow. Adjusting speed limits using enforced gantries slows traffic on the approach to congestion. The capacity of the network is increased and traffic jams can be avoided. Enforcement technologies are also used for road user charging. For example, cameras and automatic number plate recognition systems, or ANPR, are used to monitor and enforce the London congestion charge and low emission zones. Similarly, car parks and police officers use ANPR for management and enforcement purposes, including checking tax and insurance status. The analysis of road safety statistics has generated many insights that have revolutionized how we approach vehicle and road design and driver training. For example, analysis of the blood alcohol concentration of drivers involved in severe crashes led to the legislation that limited blood alcohol content. Many of the technologies described in this presentation depend fundamentally on the collection, aggregation, analysis, and communication of data. This creates opportunities to use and share this data in order to advance road safety. For example, by analysing trends in collision types by location, contributory factors, road type and/or income deprivation could enable roads operators to devise more effective interventions and vehicle developers to create safer vehicles. From the earliest in-car radios to the latest Bluetooth connected touchscreens, entertainment technologies are a key component of the user experience in most vehicles. Increasing sophistication and connectivity of these systems has enabled a huge increase in functionality available to vehicle occupants, and manufacturers market their vehicles based on the capabilities of their connected technologies. However, access to this functionality requires the system operator to navigate touchscreen menus, and in the absence of haptic feedback, a driver must take their eyes away from the road to interact with the touchscreen system, and driving simulator research has demonstrated the distraction risk this poses. The advent of advanced smart speaker devices in the home has seen much progress in the use of voice interfaces, which may have useful application for in-vehicle system interactions. So to conclude, technology is an essential element of safe road transport and continues to offer new approaches to tackling sources of road risk. Increasingly sophisticated driver assistance and automation systems will dramatically change the role of the human driver, potentially making journeys safer, more comfortable and more reliable. Similarly, advanced traffic management and communication systems, supported by in-depth data collection and analysis, will transform how we understand and operate our road networks. However, we must also be vigilant of the potential for new technologies to generate new and unforeseen sources of risk. For example, in managing transitions between automated and manual driving modes, in creating new cybersecurity risks, or in creating interfaces that become distracting for drivers. RoadSafe's role will continue to be in bringing stakeholders together to ensure that the development and deployment of new safety technologies helps to achieve the vision of a road transport system with 0 deaths or serious fatalities. Thank you very much for your attention, and I hope you enjoy the Festival of Road Safety. Thank you very much.